Number 1. Your experiment output as well as a quick run through on what you did on this experiment. So for this experiment, I analyzed the root locus of a control system using MATLAB. The main goal was to understand how the closed loop poles move in the S-plane as a controller gain K changes, and how this movement affects the stability of the system as well. So in the experiment, there was a given open loop transfer functions G of S and H of S, and I first determined the open loop pole 0 plot. I found that the system was initially unstable because the poles was located at S valued at positive 10, which lies in the right half of the S-plane. After that, I evaluated different values of S sub 0 or S sub O and computed the magnitude using the magnitude criterion and angle of G of S, H of S, which also uses the angle criterion to determine whether those points satisfies the root locus angle condition of negative or positive 180 degrees. So next step is that I run the MATLAB command rlocus nd to generate the root locus plot and compared it with the values in our table. I simulated the step response for k equals 4 and k equals 6 as well, and both responses diverged, confirming that the system remained unstable. The plot showed that increasing the gain caused a response to diverge faster, which illustrates how gain directly affects system stability. Number 2. Discuss on the challenges in performing this experiment or understanding the concepts. So one of the main challenges in this experiment was understanding the angle condition and verifying whether a point lies on the root locus. The calculation involved complex numbers, angles, and interpreting the MATLAB plot, which could be confusing at first. Another challenge was accurately selecting points using the rlocfind tool, because even small differences in the cursor position could slightly change the computed gain value. Lastly, notes to self or anything worth noting. So a note to myself from this experiment is that root locus is such a powerful tool or visualization tool in control engineering. It helps predict how the system behaves as the gain changes and allows engineers to determine whether the system will be stable, unstable, or oscillatory. It also reminds me that pole locations are directly related to system stability, so understanding the S-plane is very important when designing control systems. So that would be all.